The base unit of impulse is kg meter per second. Impulse equals to force into time, I equals to velocity. Change in momentum equals to impulse. Newton second ns is also a unit of impulse or change in momentum, but not the base unit. In question 1, which row of the table identifies what happens to momentum and kinetic energy in an elastic collision? Option A, momentum conserved and kinetic energy conserved. Option B, momentum conserved and kinetic energy not conserved. Option C, momentum not conserved and kinetic energy conserved. Option D, momentum not conserved and kinetic energy not conserved. The correct answer is A, because an elastic collision is defined as a collision in which kinetic energy is conserved. This eliminates options B and D. Momentum is always conserved in all collisions, hence only option A is correct. Correct answer is A. In the 90s, group of scientists investigated collisions of alpha particles with protons to determine whether the collisions were elastic. The diagram shows an alpha particle before and after a collision with a stationary proton. Before collision, the alpha particle and proton. Momentum of alpha particle before the collision is 1.26 into 10 to the power minus 19 Newton second. After collision, momentum of the alpha particle 8.06 into 10 to the power minus 20 ns. And this is the original direction of the alpha particle, the base. Show that the momentum of the proton after the collision is about 5.0 into 10 to the power minus 20 ns at an angle theta, while theta is about 20 degrees. Part A answer, momentum before collision equals to momentum after collision. Momentum of alpha particle before equals to momentum of alpha particle into cos 10.2 plus momentum of proton into cos theta, where theta equals 20 degree given in the question and P equals to mv. 1.26 into 10 to the power minus 19 equals to 8.06 into 10 to the power minus 20 cos 10.2 plus mv cos 20. mv cos 20 equals to 4.667 into 10 to the power minus 20. P equals to mv, so P cos 20 equals to 4.667 into 10 to the power minus 20. P equals to 4.9 into 10 to the power minus 20 ns, which is close to this value. Always keep the answers in 2SF. Deduce whether the collision was elastic. Mass of alpha particle equals to 6.64 in 10 to the power minus 27 kg. This is the answer of part B. Kinetic energy equals to momentum squared divided by 2 into mass. Kinetic energy before equals to 1.26 in 10 to the power minus 19 whole square divided by 2 into 6.64 in 10 to the power minus 27. This is equals to 1.195 in 10 to the power minus 12 joule. Kinetic energy after equals to 8.06 in 10 to the power minus 20 whole square divided by 2 into 6.64 in 10 to the power minus 27 plus 4.97 in 10 to the power minus 20 whole square divided by 2 into 1.67 in 10 to the power minus 27. Kinetic energy after equals to 1.23 into 10 to the power minus 12 joule. Since the kinetic energy after collision is greater than the before, so no energy is lost, so the collision is elastic. Kinetic energy after equals to kinetic energy of alpha particle after plus kinetic energy of proton after. Kinetic energy before equals to kinetic energy of alpha particle before.